Welcome back. Here's section 7.1, example number 2. This time we're not given the parabola in standard form, we have to put it in standard form first. In order to do that, we need to complete the square. So I'm going to find the one that has the x squared in it, or the squared guy in it. And so I'm going to put anything that is an x on one side, and I'm going to move the 6 to the other side so that I can complete the square on the right-hand side. So that means I've got y minus 6 is equal to negative 1/4 x squared plus 3x. Now, if I complete the square right now, whoops, let me parentheses around that. If I complete the square right now, it would look really funky because I've got that negative 1/4, and so I can't complete the square with a leading term that's not 1. So what we'll do is we'll multiply the entire equation by negative 4 to get rid of this fraction, and that'll help us out a little bit. So if I multiply everything by negative 4, I'm at negative 4y. Negative 4 times negative 6 is 24. On the other side, the negative 4 times the negative 1/4 means that goes away, and I have positive x squared, and negative 4 times 3 is negative 12x. All right, so now we want to complete the square over here. Remember, to complete the square, we divide that middle term by 2 and square it. So negative 12 divided by 2 is negative 6. Negative 6 squared is 36. But if I add 36 to this side of the equation, I need to add 36 to the other side. All right, over here I've got 36 plus 24. Oh, I'm parenthesis happy today. 36 plus 24, let's see, 4 plus 6 is 10, so that's 3 plus 1 is 4 plus 2 is 60. Check my math there, but I think that's right. On the right-hand side, I'm looking for two numbers that multiply to 36, subtract a negative 12, and that would be x minus 6 squared. And then we want to factor out this negative 4 as well, so that we can get it into standard form. If I take out the negative 4, I get y minus 15. And then x minus 6. So unfortunately this guy, because the vertex is at 6, 15, we're going to have to do some scaling because it's not going to fit on the graph. So by scaling, I just mean our graph is going to have to go by 2 so we can make it try to fit. All right, which way does this guy open? It is an x squared, so it's either up or down, and the focal width is negative 4, so this negative tells us where it's going to open down. So let's first graph the vertex. We're going to go by 2's. 2, 4, 6, that's my x value, and then 2, 4, 6, 8, 10, 12, 14. So halfway between there and the next one would be 15. All right, our focal width value is 4p, and this time it's equal to 4. So p is equal to 1. A lot of students said, well, isn't it negative 4? This is negative 1. That's really debatable, but to me, p is a distance, so I don't really make it plus or minus. I would take off points if you made it minus 1, as long as you understood which way this guy was opening up. All right, so since we're opening down, we're going to go down 1, but keep in mind we're going by 2, so down 1 is just right here. You can see that. And then up 1 for our directrix. So our directrix is this line right here. All right, and since our focal width is 4, we're going to go 4. So remember, we're going by 2. So 2, 4. Oh, it's 4 across, sorry. We're going to go 2 across and 2 across. So this is total width of 4. And so here's our little parabola. With a focal width of 4, it opens down. Its vertex is at 615. So let's erase this so I have some room. Our focus then was at 6, and then 1 down. Woo. Miss Harris, this is not 615. This is 6 negative 15. I am so sorry, guys. So here's 6, and we're going to go 2, 4, 6, 8, 10, 12, 14, 15. We'll still go down 1 for our focus. This is still our directrix. So sorry. And then we're still going to focal width of 4. So this is actually the parabola we're looking for. So ignore this down here, sorry. Our focus is 1 less than 15, so that would be 614. Our directrix is 1 higher, so we're going through the y-axis at 1 more than 15, which is at 16. And our axis of symmetry that cuts this parabola in half is x is equal to 2, 4, 6. All right, B. Let's put this guy in standard form. Again, we've got to complete the square to get started. Notice I've got x squared, so I'm going to put the x on this side, x squared on this side. Anything that's not an x is going to go to the other side. So I got 4y minus 3, and then there's a plus 7 over there. Uh-oh, I don't have a middle term this time, do I? That's great. That means we don't have to complete the square. All we need to do is clean up this right-hand side. So x squared is equal to 4y, 7 minus 3 is 4. And then we're going to factor out that 4, and we're going to get 4 times y plus 1. So the vertex for this one, we don't have any shift to the left or right for x, so it's right there at 0. And then -1 for the y. My focal width is 4p, and that means it's 4. So 4 is equal to 4p, dividing by 4, p is equal to 1. So we know from our vertex, which is at 0, -1, we're going to go down 1 for our focus, up 1 for our directrix. So our focus, wow, I'm really messing this one up today. Sorry, is this parabola opening up or down? It's x squared, so it is an up-down parabola, but this time, what is my focal width, positive or negative? It's positive, so it's not opening down, it's opening up, which means my focus is on the upside, my directrix is on the downside. You guys are probably screaming your heads off at home right now. All right, there you go. So our focus is going to be at 0, 0. Directrix is at y equals -2. Our focal width is 4, so we're going to go to the right 2, to the left 2, and then draw a pretty parabola. And the axis of symmetry that cuts this guy in half is right there at x equals 0. All right, looking at the U try. Again, we need to put this in standard form. It's the y that's squared, so we're going to keep the y squareds, or anything that's with y in it on this side. Everything else gets moved to the other side. We can't complete the square, however, until we get that 3 factored out, because your leading coefficient has to be a 1 to complete the square. So if I factor out the 3, this becomes 2y. Save room to complete the square. Over here I've got 12x minus 15. I'm not going to factor that 12 out until I get finished completing the square. All right, half of 2 would be 1. 1 squared is 1. And keep in mind, you're not adding just 1 to the side. You're adding 1 times 3 to this side, which means you're going to add 3 to the other side. So this will be 3. The two numbers that multiply to 1 add up to 2 are 1 and 1. So 3 times y plus 1 squared. And here I get 12x. -15 plus 3 is -12. Last step to get, well, second to last step to get it into standard form. First, we want to factor out this 12, and we get x minus 1. And then the p guy goes on the side that doesn't have the squared in it. So I actually want to divide by 3 and get that moved over so we can really figure out what that p is. So standard form, the squared guy is always by itself. Your focal width belongs to the one that's not squared. So since y plus 1 is squared, it's going to stay over here by itself. 12 divided by 3 would be 4. We've got x minus 1. Our vertex then is at 1, -1, right here. Since our focal width is 4, p is 1. Let's see, this is y squared, so we're either opening to the left or to the right. Since it's positive, we're going to the right. So since p is 1, I'm going to go to the right 1 to draw my focus, left 1 to draw my directrix. So the focus is at 2, -1. Directrix is at x is equal to 0. Focal width is 4, so we'll do 2 up and go down 2 for on that focus, draw the curved parabola. And so the axis of symmetry that cuts this guy in half is going right through that y-axis at -1. And that is it for example number 2. Come back and we'll work on example number 3.